Hi everybody, welcome to another video in Trigonometry, section 2.5. On this section we study about some application of right triangles. So first application is about bearings. So different type of bearing, but the problem we have in the book, we define the bearing based on the north and south. Could be north and south. So if we talk about the different type of bearing when we just have just based on the north. So there's another bearing. Usually if you go on an airplane on an travel by on an airplane, look for where it is, and that will show the bearing, the direction where it goes. So pretty much if the direction is not on the top, south, east and west, a bearing that if we go true north, that will be 0 degrees, and go clockwise. So 0 degree is north, 90 degree is east, 180 degree is south, and 270 is west. This is one type of bearing. So if we say I travel 45 degrees bearing, so that means between north and east. So that's one way to use the bearing. The bearing we use in our section is based on the due north or due south. So pretty much we can go from north or south an acute angle. So the answer is always in the acute angle, and it go from north to the east side on the west side. So for example, this is 40 degrees. We will write this is north 40 degree on the east side. It's always with respect to the north or south, and we always go to the left or right, east or west. So this is going to be north and go on the west side, and the angle is always have to be the angle from north to that direction. If the whole right angle is 90 degrees minus 40, that will be 50 degrees. So this the bearing of that direction. So if we stand from here and go in that direction, it is north 50 degree west. Or sometimes, usually we talk between the two friends and we say, okay, at your 6 o'clock, that means if somebody tell me, look at your 6 o'clock, that means it is 12 o'clock in front of me. The 6 o'clock should be right behind me. So I have to turn 180 degrees to look. So if my friend tell me, okay, look at your 6 o'clock, I will look right behind me, because that is my 6 o'clock with the 12 o'clock right in front of me. Or I said at your 3 o'clock. So if it is 12 in front, the 3 o'clock will be on this side. So I will turn on that side and look for the 3 o'clock, and then so on. So that kind of like the bearing. But this bearing we use the north south, and we go east and west. So for example, this is on the south side going down and to the west side. So we say south 65 degrees on the west side, and this is south 30 degrees from the east side. So always start with north and south and go direction of east or west with an angle. Okay, here's an example. A camper leave camp high 2 miles due east, and then turn and high 5 due south. From the camp, what is the bearing of her new location? So first, we start here, and she walks height 2 miles due east. Is it on the right? 2 miles east, and then turn and high 5 miles due south. What is the bearing? Okay, remember the bearing is with respect to the north south. So So we have to draw the north south here. That is north, this is south, so it have to be south something. And we have to find this angle. And we say south that angle on the east side, so south that east. But that angle we have, because C travels south and that is also south, so these are two parallel lines, the transversal, so this is also the angle we're trying to find. So these two angles are the same. And that angle, let's say A. With respect to this angle A, that is going to be opposite. And this is going to be adjacent with respect to that angle. So we write sine of A, we don't know A, equal to opposite. I'm sorry, I should say it. We have opposite and adjacent. What trig function that have opposite and adjacent? And then we say, okay, opposite over adjacent would be tangent. And opposite to adjacent is 5. So 2 over 5. And then the angle A will be the tangent inverse of 2 over 5. Now, so just use the calculator. Now this, we assume we want the degrees measure, so make sure you have in degree mode. The default usually radian, but before we do, make sure it's in the radian mode or the degree mode. So this is in the degree. So tangent inverse of 2 over 5. And you have about 21.8 degrees. So the answer, the bearing will be south 21.8 degree on the east side. Okay, just like that. Now, we have these scenarios. The bearing from a disabled ship to a rescue vessel is south 59 degrees east. So this is 59 degrees here. And the bearing to the nearest port is 57 degrees north, 57 degrees east. So that direction to the port. The bearing from the port to the rescue vessel is south 31 degrees west. So we have those angles. Assume the rescue vessel is 56 miles from the port. Rescue vessel is 56 miles from the port. So we have this distance. For the distance between the rescue vessel and a disabled ship, so let's try to find this distance. Okay, now first, remember, this is application of right triangle. We don't even know if it is the right triangle or not. So let's find out if it is the right triangle. So first, this angle, we're trying to find that angle D from the straight angle 180 degrees. If we subtract 57 and 59, we should have the angle D. 180 minus 57 minus 59, and we have 64 degrees. So this is 64 degrees. So that's nice. Then say, okay, then how do we calculate this angle, or how do we calculate this angle P? Okay, so here's the things. We have two parallel lines because that align north-south. This angle and this angle form a transversal and two parallel lines, so they must be add up to 180 degrees. So 57 degrees plus whatever that is 180 degrees, because they can form transversal and two parallel lines. We have 123. So that is 123 degrees. And now the whole thing 180 degrees, subtract 123, subtract 31. That is angle P inside the triangle. 180 minus 123 minus 31. Equal to 26. And now the angle R. D, R, and P add up to 180 degrees because that's a triangle. (180) minus 64 and 26. Well, that's exactly 90 degrees. Okay, good. So we have the 90 degree angle here. So we have a right triangle. Otherwise, we won't be able to do it yet. Okay, so now we have a lot of angles. Let's do the angle D here. It's 64 degrees. That angle D. Okay, now with respect to that angle D, 56 is opposite from that angle. And this DR, we want the distance between the rescue vessel and disabled ship, so we ask for DR. So DR is the distance X that we're trying to find. Okay, which is in with respect to that angle is the adjacent. So we need the ratio that have opposite and adjacent. Well, that would be tangent, right? So we say tangent of 64 degree or tangent of angle D, 64 degree, is equal to opposite over adjacent. So tangent of 64, and we have tangent of 64 degree, opposite is 56, adjacent we don't know, but it is going to be X. We'll try to find. And now we just solve for X. Cross multiply X tangent 64 degrees equal to 56. So X equal to 56 divided by tangent of 64. Again, every time if it 1 degree, make sure it is in degree. Otherwise, it should be in radian. Right, 56 divided by tangent of 64 degree. And that would be 27.3 mile. Look reasonable though. Angle 26 is smaller than 64, so this distance have to be smaller than 56. Right. So that. Next, moving on. So this is another application, not really related triangle. Pretty much we're going to have two triangles. Okay, some nice application though. Remember, I think on the first few days we talked about how do we measure the length, the height of a pyramid. The pyramid is very wide basis, very wide base. It's very difficult to see where it is. Okay, let me draw out it so to get the idea. So if you have a pyramid, just look at the 2D picture and you say what is the height? Well, it would be very difficult to know, to go at the middle of the pyramid and then measure the height. So in that case, there must be a different way. And the way to do that is you stand here at an angle, measure this, and then step back, measure another angle. And with that, we can find the height. Okay, here's the sample. A ranger find that angle elevation from his current location to the tower is 28.3 degrees. So he looked at 28.3 degrees. He looked to a tower and he said, okay, that's 28.2 degrees. That's all he knows. And then he walked 50 feet toward the tower. He walked that, and now we look up to the tower again. That is 31.2 degrees. So we don't even need to get close to the tower. Suppose if there's a lake in between and we cannot really get to it, or if there's a rock or building or whatever, we cannot get there. How do we measure the height of the tower? And this is exactly what we do. By the way, we assume that it's going to be flat surface and the tower is 90 degrees from the ground. So how do we calculate this? Okay, so like I said, we don't need to get close to it. If there's a fencing or whatever it is, we can just do this. Look up to the tower, walk a distance, and look up to the tower again. Find two angles. Okay, how do we do this? Okay, so let's say we want interest in the height of a tower. We're looking for that. And we won't be able to get that directly. Let's put some letters so we can. So this is A, and this is C, this is B, and D. Okay, so let's look at the triangle ADC. ADC. With respect to this angle, we have opposite, and this time we're going to use adjacent. And let's say this distance we don't need to know, so that let's call that B. Oh, actually should be fitting to call that A, because that opposite from the angle A. So that distance from B to C is called that A. And so in the big triangle ADC, we can say tangent of D is equal to opposite over adjacent. Adjacent is A plus 50, not just A. This is A plus 50, so A plus 50. And with that, if we cross multiply, we have H equal to tangent D times A plus 50. Okay. Now let's look at the triangle ABC. Now we have tangent B is H over A. Right? Opposite over adjacent, that tangent. And that gives us H. If we cross multiply again, we have H equal to tangent of B times A. And the nice thing is that both of these equal to H, so they will equal each other. So we have tangent of D times A plus 50 equal to tangent of B times A. Okay, I will keep that multiplied out. That will be A times tangent of D plus 50 times tangent of D. We know D, we know put tangent of D, that's easy, that's just a number. So we could keep that as 50 times tangent of D. And here we write A times tangent of B. And we solve for A. So we subtract A tangent B on both sides. And that gives us A tangent D minus tangent B. And we're going to add this on both sides. Sorry, we should subtract that on both sides. That's negative 50 tangent of D. And then divide by the parentheses on both sides, we have A is equal to negative 50 tangent of D over tangent D minus tangent of B. So to recap, we try to find the height, but won't be able to find the height directly. This we know for both triangle ABC and ADC, we can solve for H. And since both of them equal to H, they equal to each other. We let them equal each other, and we can find the missing variable A. Once we know A, we have the rest of the problem. Okay, so if we want fraction will be alpha y equal negative 50 tangent of D. D is 28.3. And then at the bottom, tangent of D, tangent of, D minus B. So this is D. Tangent of 28.3 minus tangent of B, 31.2. And we have about 400 something. So A is about 400. So when we do that, we have A is equal to 400. The unit is feet. So 400 feet. And finally, the height is equal to tangent B times A. Tangent of B is 31.2. So tangent of, make sure that it is in degree. Second mode. We should check for it. Make sure in the degree mode before we actually do this. Now, tangent of B, 31.2 times A. A is about 400. And we have 242.25 feet. So this is a very nice application. We don't need to approach to the tower and standing further apart. We still can find the height of it. Assume that all of that on the flat plane, and the angle, in reality the angle can be measured very accurately, more so than the distance. But at least if we have all this information, we can find the height of the tower is 42.25 feet. Okay, look at another example. A tower that is 150 feet height. And 50 feet. With the sun directly overhead, an airplane, so an airplane on top here, cast a shadow and have an angle elevation of 67.4. So this is angle elevation. And angle depression of 8.1 with the shadow. So the airplane here, the shadow here, the angle depression is 8.1 degrees. find the height of an airplane. So looking for this, right? So in this case, we won't be able to find that directly because that's not a right angle. But there will be two right triangles here. One of which is this and one not is. Let's put some letters. Let this be H and the angles, let's say C. So we have the triangle of CH and A and CH and S. By the way, the tower, if the line of sight, we look straight out. If this is 150 feet, the HS, this is also 150 feet. And in that case, if we have that, we can find CH, because CH belong to this triangle and belong to that triangle too. If we find CH, we can use that CH to find AH. So the game plan is we look at the triangle CH and S, try to find CH. After you find CH, we look at the bigger triangle CAH, and then we know CH, we can find AH. And finally, the height of an airplane will be from S to A, which is S to H and then H to A. So 150 feet plus AH. So that is the game plan. So first, the triangle CHS. We have HS, the angle is 8.1 degree. So the angle is 8.1 degree. And with respect to that, this is opposite 150 feet. And the CH is adjacent to that angle. So we write the ratio that have opposite and adjacent, because that is tangent. So tangent of angle C is opposite over adjacent. So C is 8.1, opposite 150, adjacent CH. We solve for CH. Cross multiply. So CH tangent of 8.1 degree equal to 150. CH times this is 1 times that. Cross multiply. Divide by tangent of 150, we have CH 150 divided by tangent of 8.1 degree. (150) divided by tangent of 8.1 degree. We have 1054. Let's round that. And unit is feet. So we have CH is 1054 feet. So that's the first part. Next, the triangle CAH. We have angle C is 67.4 degree. The opposite to the angle C is AH, which we don't know. We're trying to find it though. We know adjacent is CH, which is that. So we can say, okay, what ratio that have adjacent CH and opposite? So again, that is tangent. Tangent is opposite over adjacent. Opposite, don't know. Adjacent, CH equal to that. Now we just cross multiply and we have AH is equal to 1054 times tangent of 67.4 degrees. 1054 times tangent of 67.4 degrees. And we have that 2,532 feet. And with that 2,532 feet plus 150, that will be the height of the airplane from the airplane to the ground. So we have AH is 2,532 feet and HS 150 feet, and we add them. 2,532 plus 150, 2,682 feet. That's the height of the airplane from the ground to the airplane. So that's what we have. Right. With that, we finish section 2.5. Thank you for watching.